Hello everyone. Today we are going to do the experiment verification of superposition theorem. For this we are taking a T network of 50 ohm each in the side branch and the middle branch is of 10 ohm, and the two voltages are 12 volt and 5 volt is taken. Superposition theorem states that in any linear active bilateral network, if there is two or more than two sources are present, then the voltage across or the current through an element is algebraic sum of the voltage across or the current through that element, while each individual source acting alone, while all other sources are deactivated. Let us consider here, if we are considering one voltage source, then the other voltage source will be turned off, and as the internal resistance of the voltage source is 0, so voltage sources will be short circuited and the other current sources will be turned off, and as the internal resistance of the current source is infinity, so the current sources will be open circuited. So here we are considering a network that is of T network having 12 volt source and 5 volt source. As superposition theorem suggests that 12 volt source can be activated and 5 volt source can be deactivated. So we are first considering the 12 volt source. This is the circuit diagram while considering the 12 volt source and deactivating 5 volt source. As the voltage source is the 5 volt source, so we are deactivating it, so it is replaced by a short circuit. Now for the calculation of various values of I1 dash, I2 dash, I3 dash, we are applying nodal analysis here. So the equation for this nodal analysis is, we can say that 12 minus V dash by 50 plus 0 minus V dash by 50 is equals to V dash by 10. From here what we are getting is 12 minus V dash by 50 is equals to V dash by 10. So from where we are getting the V dash value is 12 by 7, that is 1.71 volt. And we are taking this voltage as V dash because we are considering only 12 volt source only. So now you can see the equation I1 dash is equals to what? 12 minus V dash by 50 ohm, and I2 dash is equals to 0 minus V dash by 50, and I3 dash is equals to V dash by 10. So from here we are getting the I1 dash value, that is 12 minus 1.71 by 50, that is 205.8 milliampere, and I2 dash is equals to 0 minus 1.71 by 50, that is minus 34.2 milliampere, and I3 dash is equals to V dash by 10, that is 1.71 by 10, that is 171 milliampere. We got the currents across each resistor while considering only 12 volt. Now we are considering the 5 volt only, and 12 volt source is deactivated. It is a voltage source, so it is replaced by a short circuit, and now we will apply KVL for this 5 volt source only. So applying KVL at node V dash double dash, that is as we are taking here 5 volt source only, so we are taking the node as V double dash. So by applying nodal, what we are getting, that is 0 minus V double dash by 50 plus 5 minus V double dash by 50 is equals to V double dash by 10. From there what we are getting is minus V double dash plus 5 minus V double dash by 50 is equals to V double dash by 10. From this equation we are getting the voltage V double dash is equals to 5 by 7 volt, which is 0.71 volt. So as we got I1 dash is equals to 0 minus V double dash by 50, that is equals to minus 5 by 7 divided by 50, that is minus 14.2 milliampere. I2 double dash is 5 minus V double dash by 50. So the resultant value we are getting is 85.72 milliampere. And I3 double dash is V double dash by 10, that is 0.7142 by 10 is equals to 71.42 milliamp. So now by applying superposition theorem, we are getting I1 is equals to I1 dash plus I1 double dash. So I1 dash we got 205.8 and I1 double dash we got minus 14.2 milliampere. So from this the resultant is 191.6 milliampere. Similarly, I2 is equals to I2 dash plus I2 double dash, that is minus 34.2 plus 85.72, that is equals to 51.52 milliampere. And I3 is equals to I3 dash plus I3 double dash, that is equals to 171 milliampere plus 71.42 milliampere, that is equals to 242.4. Now we can verify this by considering both the sources and applying nodal at node V. So from here what we are getting is 12 minus V by 50 plus 5 minus V by 50 is equals to V by 10. From this equation we are getting that 12 minus V plus 5 minus V by 50 is equals to V by 10. By solving this equation we are getting V is equals to 17 by 7, that is equals to 2.42 volts. The voltage is 2.428 volt. So from here I1 we got 12 minus V by 50, which is 191.6 milliampere. I2 is equals to 5 minus V by 50, that is 5 minus 2.42 by 50, that is equals to 51.6 milliampere. And I3 is equals to V by 10, that is equals to 2.42 by 10, that is 242.8 milliampere. Now this is the circuit which is inbuilt in the kit to verify the superposition theorem. This is the particular circuit in which superposition theorem will be verified. The two supply voltages are given here, that is 5 volt DC and 12 volt DC. So here we will connect this 12 volt to the positive terminal of supply, then the ground will be connected to the ground of 12 volt supply. Now 5 volt will be connected, that is to the 5 volt supply. Then the ground of 5 volt is now connected to the ground of 5 volt. Now we will measure the current across each branch. Before that, first we will design the circuit. So these 2 points are given for the current measurement. So this is sorted now. This one is also sorted. And the middle branch also sorted. The connections here, the positive supply is provided to 12 volt, ground is connected to ground, and the 12 volt supply connection is over. Now 5 volt positive is provided to the 5 volt of this circuit, and ground of the 5 volt is given to the ground of the circuit. Okay, now all the ammeter connections, not this one, all the ammeter connections are sorted now. Now we will measure the current across each branch. So first we will disconnect this and connect the ammeter. Here ammeter is there, a multimeter is taken as ammeter. So this is connected, ammeter positive supply is connected to the one end of the circuit and the ground is connected to the other end. Series connection is over. Now we will give the supply and measure the current I1 when both the sources are active. So when both the sources are active, it gives the reading 0.196 ampere. Okay, now we will disconnect these two terminals and sort this one and measure the current I2. So this is sorted. Now we will measure the current I2. So disconnecting this and connecting the ammeter here, that is this point is connected to the ammeter and switching on the supply, we are getting the current is 0.051 ampere. It is showing ampere here. So it is showing 0.052 ampere, that means 52 milliampere. So when both the sources are active, the current I2 is 52. Now let's disconnect the multimeter from I2 terminal and sort these terminals. So this terminal is sorted. Now we will disconnect the I3 terminal and measure the current here. So ammeter is connected now. So this will give you the current reading as 246 milliampere, as it is showing 0.247. It's 240. It is changing actually. So it's 0.248 ampere. That means 248 milliampere. So we have taken the readings of I1, I2, I3 when both the sources are active. Now we will take the reading when 12 volt source is active and 5 volt source is deactivated. So switching off the supply and disconnecting the 5 volt source. This is disconnected from the supply and the source is also disconnected. And remember one thing, we should never short this terminal as we are deactivating the 5 volt supply. That means if we are sorting these two terminals are sorted. If these two terminals are sorted, then the supply voltage 5 volt will be directly be sorted. So this should not be sorted. We should sort here in these 2 points. Okay, so we are sorting here. Now 5 volt source is sorted. We will measure the current across the middle branch, that is, let us switch on the supply and it is showing the reading 0.175 ampere, that means 175 or 6 milliampere. Now let's disconnect the ammeter and sort here. We will sort this one. Before that, switch off the supply and sort this terminal. this is sorted and measure the current here, that is I1 dash. So disconnected this, connecting the ammeter here, connected the positive terminal and the negative terminal. Now let's switch on the supply and measure the current, and it is showing 0.209 ampere, means it's 210 ampere, that is 2, actually it is varying, so that is 0.211 ampere or 212 milliampere. Now let's switch off the supply, then disconnect these two terminals, sort this one, this is sorted, then for measuring I2 dash we are disconnecting these two terminals and ammeter will be connected now. So that is the current across 50 ohm resistor, that is R3, and we have taken this as I2, that is equals to minus 0.035, as we got in the theory case also, that is 0.035 ampere, so 35 milliampere. So now let's disconnect this one and give 5 volt supply, and let's sort the 12 volt source. So now we will open circuit this one and 5 volt supply will be given to the right hand side of the circuit. So this is disconnected and connected to the ground of 5 volt, and this I am disconnecting here and connecting here, and this 12 volt is disconnected from the supply and sorted here in this point. Now the connection is over and already the ammeter is connected across I2. So let us measure this one by considering 5 volt and sorting the 12 volt source. Similarly, likewise, you cannot sort here this 12 volt or this 12 volt here. Okay, if you are sorting this one, then the source will be sorted directly and there is a chance of damage of the kit. So you should not sort here in these 2 points. Instead, you should sort in these 2 points. Okay, then let's measure the current and switching on the supply. The current is, so the current is, it is showing 86 milliampere. Again you can see the unit ampere written here. Actual value is writing here, that is 0.086 ampere or 0.087 ampere. So this is, we can take it as 86 or 87 milliampere. Now let's disconnect this one, sort here, sort this terminal and measure the current I1. So let's sort this. This is sorted. Now disconnect this terminal and ammeter will be connected here. So connecting the ammeter connected the ammeter here and switching on the supply. Now let's take the reading. It is showing minus 0.014 ampere, that is minus 14 milliampere. Now we need to measure only one current, that is middle branch current. So let us disconnect this one and connect the ammeter across the middle branch. So first switch off the supply, then disconnect this terminal from the ammeter, short this terminal and disconnecting this middle branch, connecting the ammeter here, connecting the ammeter here, and now let's switch on the supply and measure the current. So it is showing 0.072 ampere, that is 72 milliampere. So you can now tabulate these readings of I1, I2, I3 when 12 volt source is active, 5 volt source is active, and when the both sources are active, and can verify that whenever you are adding the currents, when 12 volt source and 5 volt sources are active individually, the resultant current is equal to the when both sources are active. So thank you all.